Okay, so we're on section 5.5, roots of real numbers. So I feel a little bit bad doing this to you on Monday, but this is one of the hardest sections that we're going to have, so you need to pay attention. Make sure you understand it. Okay, so it says we know that squaring something and taking the square root of something are inverses of each other. In other words, they undo each other. Similarly, there are roots that are inverses of larger powers as well. Okay, so it starts out pretty easy. So 5 and negative 5 are square roots of 25. Because we know that 5 squared equals 25, and negative 5 in parentheses squared equals 25 as well. Okay, so the next one, 2, is the blank of 8. So 2 is the, you know what it's called? What kind of root? Cube root. So 2 is the cube root of 8 because 2 cubed equals 8. 2 and negative 2 are the fourth roots of 16 because 2 to the fourth equals 16 and negative 2 to the fourth equals 16 as well. And then A is the nth root of B. So A is the nth root of B. That's what we're saying right there. If A to the n equals B. Okay, the nth root of a real number can be written as the radical expression nth root of A, where n is called the index, and A is called the radicand. So the part under the radical sign is the radicand. Okay, I'll usually just refer to these as what root and what's inside the root. I don't usually call it the index and the radicand because I think most people usually forget what that is. When a number has more than one real root, the radical sign indicates only the principal or positive root. Okay, that's one of the most confusing parts for people in this section. So if the root is already there, so it says if we see square root of 16, we know that it's just positive 4. So when you guys see this, it's just positive 4. Even though there are two numbers that can be squared to get 16, 4 is called the principal root. But if you have an equation, so if I had x squared equals 16 and I wanted to solve for x, what would you do to solve for x? You would take the square root of both sides, right? So if you were the person taking the square root, so the square root was not already there, but when you're solving, you take the square root, you have to write plus or minus. So then it would be x equals plus or minus 4. Okay, so that's the thing that's kind of confusing. So if the square root is already there, it's already representing the positive root. Okay, if the square root was not already there, then and you take it, then you need to write plus or minus. Okay, so let's say we're solving an equation. So let's say I had x cubed equals 8. That means what kind of root am I going to take to get rid of the x to the third? If I just want x. Not a hard question. What kind of root do I take? Cube root, right? So I'm going to take the cube root of both sides. How many answers will you have? Yeah, the answer will be 2, but how many answers are there? Just one, right? So if you have an odd n, so this is an odd index, there's only one solution. Because negative 2 times itself 3 times doesn't make positive 8, right? There's only one answer. Okay, so now if I have an even n and it's a positive radicand, so let's say I'm taking x squared equals 25. Okay, so this is a positive radicand and an even index. You don't have to put the 2 there. If the 2's not there, you automatically know it's the square root. So you get x equals, since I took the square root, I write plus or minus 5. So there would be 2 answers. Okay, So what if it's an even root and it was a negative number? How many solutions would there be then? So x squared equals negative 16. How many answers are there? Okay. I know it's Monday. Wake up. How about Mary? How many answers do I have to this? X squared equals negative 16. No? Kendall? 0, right? There's no answers to this. Because when you take the square root, you can write plus or minus, but you can't take the square root of negative 16. You can't take the square root of a negative number. So there's no answers. Okay, and then a radicand of 0. So it doesn't matter if it's an even root or an odd root. If you had x to the 4th equals 0, when you take the 4th root of both sides, you can write plus or minus out front, but the 4th root of 0 is still 0. So there's just one answer. So these are the number of answers. Okay, so find all real roots. So if I had the 5th root of 32, so if I had 32 and I took the 5th root of it, how many answers are there? 1 or 2? 1, because it's the 5th root, right? So the 5th root of 32 is just 2. If you didn't know that, you could put it into your calculator. So here's how I put it in. I do 32 raised to the 1/5 power, like that. Make sure your 1/5 is in parentheses. You could also do 5. You can hit math. I don't know which choice it is, but it's the one that looks like this. Something like that. I think it says like nth root of x or something. So hit that button and then do 32 and enter. I usually just do it this way, though. It's easier. Okay, so cube roots of negative 125. So this would be the cube root of negative 125. Can I take the cube root of a negative number? Yeah, because something multiplied by itself 3 times makes a negative, right, if it was negative to begin with. Okay, if you don't know, you can put negative 125 and raise it to the 1/3 power. That means cube root. You get negative 5. All right, how about the next one? So 8th roots of negative 256. Two answers? 0 answers? All right, 0 answers, right? So this is no solution, because this is saying the 8th root of a negative number. Something multiplied by itself 8 times is not going to be negative. It would always be positive. So it's no solution. Okay, if you had messed up, though, and you were trying to do it on your calculator, a lot of people will put this in on their calculator like this, and they would get an answer out. Okay, make sure that this negative 256 is in parentheses, because you're raising, like you're taking the 8th root of the entire negative number. So you need the negative as well. Okay, then it will say error, so no solution. Okay, so number 2, simplify. So I'm going to have plus or minus. Since I have the square root of 16, the square root of 16 is 4. What's the square root of x to the 6th? So what do you multiply by itself 2 times to get x to the 6th? X to the 3rd, right? Okay, so on the next one, I'm going to have the negative out front again. So I have something to the 4th and then under a square root. So I would multiply that something by itself twice to get something to the 4th. So I'm going to have q cubed plus 5 squared. See how if you had 2 of those? So if I had this times, that's how I would get to the 4th. Does that make sense? Okay, it's kind of confusing. All right, how about on the next one? Okay, you can't do the 5th root of 24, right? So I'm going to leave it as 5th root of 24. What about the 5th root of 8 to the 10th? So what times itself 5 times makes a to the 10th? A squared. So what are you doing each time to your powers? You're dividing, right? So you're going to do 10 divided by 5. All right, so the next one is going to be b to the third. Okay, and later on we're going to talk about rational exponents, but you know how you're putting this into your calculator right now? You're like, the fifth root you put in as to the 1/5 power. Sometimes that makes it easier to think about it this way. Okay, because now I have a to the 10th to the 1/5, and what do you do to those powers? Like if I had a power raised to another power. Right, if I had, oops. So if I had x squared to the third, what did I do with those? Don't you just multiply them? You guys are so sleepy today, this is ridiculous. All right, so what am I doing over here? You see how you're multiplying them? Right, a to the 10th to the 1/5, you do 10 times 1/5. Carolyn, you with me? All right, what do you do over here? b to the 15 times 1/5. So multiply your powers, you get 3. Okay, so sometimes it's easier to think of it like the 1/5 power. Okay, and then how about the last one? No solution, right? So no solution. All right, so this C, I would probably write the a squared b to the third out front, and then I do the 5th root of 24 on the end. Just because people's, their radical line gets a little long. Sometimes people's lines go over and you can't tell what's under the root, so usually we put it at the very end. All right, so now on to the most confusing part. So I told you this section's kind of hard. Okay, so you really need to pay attention to this part. Okay, so what is the square root of -5 squared? -5? +5? Plus or minus 5? Okay. So notice the square root's there, so you need the principal root. So it's just going to give you the positive answer. Okay, but think about working from the inside out. If I had -5 squared, that's 25. And then I take the square root of 25, so I get 5. So it's the positive version of the number. So if I had the square root of x squared, a lot of people just say the square root and square cancel each other out. Okay, but that's only if x is a positive number. If x was a negative number, you now end up getting the positive version out, like we did in the first example. So what is the square root of x squared going to be equal to? So I'm getting the positive version out. What's that making you think of? It's not just x. So if that was -7 under there, I'm going to get 7 out. If it was -8 for x, I'm going to get 8 out. What am I doing? Changing the sign, but only when it's negative, right? If it was 10, 10 squared is 100, under square root is 10. So I'm only taking the positive version of it. So what's that called in math when you only take the positive version of something? You guys know this. You're killing me. So I'll just stop recording now because this is not going to be posted. Guys, what do you call it when you take the positive version of something? So if I have -7, I'm going to get 7. If I have 10, I get 10. Thank you. Someone is awake. Absolute value.
I'm giving them this.
Oh, you got a hint from Mr. Cyrick too. All right, so you get the absolute value of x out. Okay, so that means when you take an even root and you end up with something to an odd power, you have to put an absolute value. So it says if you're trying to find the nth root of an even power and the result is a number raised to an odd power. See how this was x to the first? This was an odd power, but it was an even root. You must write the absolute value of the result to ensure it's non-negative. Okay, so always think about plugging a negative number in and see what you would get. Okay, so the first example. So I have the 8th root of x to the 8th. so they don't just cancel. Think if I had a negative number in there. So if I had the 8th root of negative 1 to the 8th, we'll start easy. What's negative 1 to the 8th? Negative 1 to the 8th? 1. Okay, then you take the 8th root of 1. 1. Okay, this would end up being 1. So if I had the 8th root of x to the 8th, it's not just x in the end. It's not just whatever this was to begin with. It's the absolute value of x. All right, 4th root of 81. So what's the 4th root of just 81? So what times itself 4 times makes 81? It's usually a small number. Is it 2? No, 2 times 2 times 2, 4 times. So 2 times 2 times 2 times 2, it would be 16. Is it 3? 3 times 3 is 9. 3 times 3 is 9. Multiply them together, 81. So it's 3. You should usually be able to do this in your head. So it's 3. Okay, then I have a plus 1 to the 12th, but now it's under the 4th root. So remember, you're dividing your power, so 12 divided by 4 is 3. So it's a plus 1 to the 3rd. Okay. Think about a negative number in there. If I had a negative 2 in for a. If I had negative 2 plus 1 to the 12th, what do you get? 1. Then you take the 4th root of it, 1. So you're getting a positive number out. But if you plug in negative 2 here, you get negative 2 plus 1 is negative 1. Cube it. What do you get when you cube it? Negative 1. We wanted positive 1. So that's when you know you need the absolute values. Let's look at absolute values then. Okay, so the trick is if you started out with an even root and ended up with an odd power at the end, that's when you need absolute values. Okay, so the next one, I have an even root. So that's when I'm like, oh, maybe I need absolute values. We'll see. What do you guys think this would be? So without the absolute values, what would your first intuition be? T to the 3rd. Did you end up with an odd power? Yeah. So that means that you need absolute values around it. Okay, again, think of numbers. If you had a negative number in there, so negative 1, and I raised it to the 18th, you'd get 1. Then you take the 6th root, you get positive 1 out. That's why it doesn't just cancel and become negative 1 to the 3, because negative 1 to the 3rd is a negative number. We should have a positive number out. Okay, next up. So I have the 8th root of 2a minus 1 to the 16th. Okay, so it's going to be that whole thing, so 2a minus 1 to what power? Squared. Do I need absolute values? No. Why do I not need absolute values here, but I needed them when it was raised to the 3rd power? Because you started out with an even, and now I have an even root. So what's special about even roots? If I have a negative number and it's to the even root, what is it anyway? It's positive, so I don't need absolute values because it's already positive, right? So you can write to yourself, already positive. So this is why we don't need absolute values. All right, next one. So I have the 4th root of a to the 8th. So what's that going to be? So we do one part at a time. So 4th root of a to the 8th, a squared. Do I need absolute values? No, it's already positive. A squared is positive. All right, 4th root of b to the 12th, b cubed. Do I need absolute values? Yes, because b could be negative. All right, c to the 16th, and then the 4th root of it, c to the 4th. That's your answer. So you only need absolute values around the parts that have an odd root in the end. Okay, so usually if it's a real life problem, you can approximate radicals using decimals. We don't usually say go out a distance of 2 square root of 3 feet. That'd be weird. So we usually use decimals in real life. Okay, so it says the time t in seconds that it takes a pendulum to make a complete swing back and forth is given by the formula t equals 2 pi times the square root of L over g, where L is the length of the pendulum in feet, and g is the acceleration due to gravity, which is 32 feet per second squared. So find the value of t for a 1.5 foot long pendulum. Okay, so when I see 1.5 foot long, that means that L equals 1.5, and g we already knew was 32 feet per second squared, so just 32. So we plug in. So I get t equals 2 pi times the square root of 1.5 over 32. Okay, so try to put this into your calculator. I would do 2 times pi. There is a pi button. You don't have to do the times. If it's just 2 pi, it will do that automatically. And then you hit the square root button, and it gives you a parenthesis. So do 1.5 divided by 32 parenthesis. Okay, what do you get? So 1.360. And what do you think time is in? What's its units? Read through the problem, find it. Seconds, right? So that's your answer. Okay, 2, the relationship between the length and mass of a Pacific halibut can be approximated by the equation L equals 0.46 times the cube root of m, where L is the length in meters and m is the mass in kilograms. Use this equation to predict the length of a 25 kilogram, so m equals 25 halibut. Okay, so I put 0.46, and remember on your calculator, if you're trying to do the cube root, the easiest way to do it is do 25 raised to the 1/3. Make sure you put your 1/3 in parentheses. Okay, what's your answer? What was it? 1.345, and what's your length in? Meters, right? Okay, so with the time remaining, I want you guys to start your homework because some of these problems are hard. Remember, if you started out with an even root and ended up with something raised to odd power, you need absolute values. What if you started out with an odd root? If you just had an odd root, isn't it just whatever it is in the end? Right, if I had the odd root of a negative number, so like the cube root of -8, that's just -2 in the end. So you don't need absolute values at all for that because it's just whatever the number is in the end. Okay.